Okay, so this video follows the earlier one on recognizing congruence. This one we're going to talk specifically about if we have this idea with a right triangle, will that open up some other possibilities for us? The other thing we will look at is just some general practice. Now that we've gone over all of the different possibilities, what can we use? How can we take some givens and figure out a proof of some congruent triangles? Now, if you have not watched the first recognizing congruence video, I suggest you go and do that now. All right, so we have two pairs of triangles here, and so we said there are four usual possibilities: side, 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 angle, side, angle, or angle, angle, side. And we said that if we saw an S, it meant side, and if we saw an A, it meant angle. But that leaves this one. If we have HL, that means hypotenuse, leg. So the H, of course, being hypotenuse, the L being leg. And we know that these two things only exist in a right triangle, a triangle with one right angle in it. With this, we know that the hypotenuse is the longest side and it is opposite the right angle. And the leg is one of the two perpendicular sides. So if we have a side opposite a right angle, a hypotenuse, and two right triangles congruent, and then two legs congruent, the triangles are said to be congruent through HL, hypotenuse, leg. Again, this only works for right triangles. We don't have a hypotenuse or a leg in just any triangle. Okay? HL is actually pretty easy to identify whether or not we're even going to be able to use it. So let's take a look at our triangles in this situation. The first thing we have to ask is triangle ACN or triangle, actually I should say and, so it would be R, triangles ACN and RCN, right triangles? And the answer to this, of course, is yes. We know that angles R and A are right angles. Okay, so everything's in play here. We could have any of the four usual ones or HL. Okay, so let's go through what we know as we've done before. So we know that AC is congruent to RC. That's given to us. And we know that we have two right triangles. We've already said that. I'm not going to say it again. We can show that NC is congruent to itself because of the reflexive property. Okay, let's go through our list here. I'm going to rewrite it so I don't have to erase when we go to do the other pair. Side, 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 angle, side, angle, 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 side, and HL. Just because you have a right triangle doesn't mean HL is the answer. It just means that HL is a possibility. Okay, well, let's see what we got. Well, I see that I have two pairs of sides equal. I don't have a way to get the third side. Can't use SSS. I only see one pair of angles in this at all, the right angles. Well, those two are gone. Okay, so I have either side angle side or hypotenuse leg. We've talked about in the other video this idea of inclusion. Are the right angles included between the two sides? The answer to that is no. The right angles are not included. They're not between the two congruent sides. SAS is not a possibility. Now, don't say that HL is it though. So this is technically SSA, which is not a thing except for the case of HL. The way that you tell this is to look at the two sides. You have AC and RC are legs because they're part of the right angle. NC is across from each of the right angles. It's the hypotenuse. We do have a congruent hypotenuse and leg. We can say that triangle ACN is congruent to triangle RCN by hypotenuse leg. Again, if those were not right triangles, this would not be possible. Let's look at the one on the right. All right, so we have our list. Side, 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 side angle, side, and so on. I encourage you to do this when you are doing problems on your own. Think about the possibilities and get rid of them as you realize they are not possible. Okay, same question. Our triangle SRQ and triangle TUR, whoops, that should be TRU, right triangles? And the answer to that is no. There's no right angles marked. Right angles are not something we get to assume. HL is not going to be possible here. There can be no hypotenuse and leg without first a right angle. So let's go through what we know. We know that SQ is congruent to UT, that's given. We know that QR is congruent to UR, that's also given. We can see that we have two congruent vertical angles. Angle SRQ is congruent to angle TRU. Okay, that's all we can get. We can't get a third pair of sides. We can't get any other angles. So let's go through our list now. Can't get any other sides. Side, side, side is not a thing. We can't get any other angles. That gets rid of ASA and AAS. So it's either side, angle, side, or not possible. And we can see here that these angles are not included. They're not between two congruent sides. They're off in the other direction. This one is not possible. We know it's not possible because this would be side-side angle, which is not possible if we don't have a right triangle, which we don't here. All right, let's take a quick look at some practice. So we have this problem. Write a congruent statement if they are equal. If not, then say not possible. All right, I'm going to redraw these separated just because I think it's sometimes difficult to figure out what's going on if we have two triangles that are overlapping. Okay, so the one on the left is DBA, and this one is CBA. Okay, point E doesn't really matter here. Okay, let's mark our givens. AC is congruent to BD, and AD is congruent to BC. Okay, so this is what we know. Okay, so we have two sides equal. Okay, well, I don't have any angles. I don't have any way to figure that out. So nothing that includes an angle is possible. We don't see any right angles either, so it's not HL. It's either side, 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 or not possible. In this case, we know they both contain a side AB. So I can also say that AB is congruent to AB because it's reflexive. And so then I can say side, 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 triangle ADB is congruent to triangle BCA. Okay, I just want to mention one thing here about the congruence statement. I don't have any angles. So in order to identify which sides are congruent, I did this. I said that segment AD was first. Its congruent corresponding part is segment BC. And then I just put in the third letter. That's it.